You have a MacBook Pro, and it says it's board level. So usually when we get an assessment that comes through to say it's board level, it means the device is whatever the problem of the device is, it has to do with the board. So with this particular one, I'm very sure it's a no power. Um, I did mention before that the form factor of the 2020 Intel is exactly like this. You have a touch bar separated from the escape key, separated from the power button. This is exactly what the form factor of an Intel device will look like. However, the difference will be that you will have that sign, the emoji sign. You see that? That's not something you will find with the Intel device. So Intel device will not have. So that is specifically on M series. And the reason why that is important is if you are to use the screen for an M1 on an Intel machine, it's not going to work. Do you understand? So if you're to take this screen, for example, and then you put it on an Intel device that looks exactly like this, it looks exactly the same thing. The form factor, you look, I mean, single port, two ports on, like everything will look exactly the same. But if you transfer the screen to if you try to swap parts across it, it's not going to work. Now the reason why that is important is, imagine if you have two of these machines. You have an Intel device, and then you have an M1, and then you have an M1 of it, and the client screen. So and then also it's easier to support the 4-port version of the 2020 over the 2 ports, because with the Intel they also have the 4-port version of the same 2020, and the M1 has 2 ports, and the Intel also has the same 2 ports, same design. But with the key, with the FN, with the emojis, you can easily tell that that is an M1 device. And then why that is important is, imagine if you have a machine like this one and the screen is broken, correct? Sometimes, depending on how the type of damage you have in the screen, it could be that you have no backlight whatsoever on the screen, because the screen is that bad that, because there are some crack that you can see part of the screen still works fine, and there are others that the screen is cracked. It's so bad that you cannot even see anything on the screen. Imagine if you have a device like that, screen is faulty, you just need a screen replacement. Now you have two of this, one is Intel and one is M1. Now you, the technician, transfers the Intel screen on the M1. Mind you, this machine now, the M1 itself, the screen is so bad that you cannot even see nothing on the screen, which is, you are not 100% sure that it's actually a screen issue unless you can see a physical crack. Now you have two of those, one is Intel and the one is M1. You transfer the screen of the Intel onto the M1. Now it's not going to work. What would then happen is, you will now be convinced, especially because you know that the Intel is working. You can see that the Intel works 100%. Transferring that screen onto an M1, still on the fact that, because you were not 100% sure that the problem with the M1, it's a damaged screen or a board issue. You take the screen from the Intel and then you install on the M1, and it's still not going to work. That will now cement your conclusion that the problem is not the screen but the board. Do you understand? You have two machines. One is M1, one is Intel. The one that has a damaged screen, the screen is so damaged that you don't see nothing on the screen. In that state, you are not able to 100% say that the problem is the screen. Now you need another screen to confirm it, correct? Now you take another screen to test it, but you took a wrong screen because they look exactly the same. You install the screen and you don't get what you want. There is no image, there is nothing. You now conclude that the problem is what? Is not the screen, because you said to yourself, if it was the screen is working on this machine. It should work here. Now, the fundamental thing that's missing now is, you do not know that you have two different devices. So you can either confirm this using the serial, the model number, because they will have two different model numbers, or just by looking at the keyboard, you can be able to tell that, okay, this with this sign here, I can tell that this is an M1, And if it's an Intel device, the FN will not have. So let's just see. So this is an Intel device, even though this is not a 2020, this is a 2016, 2017. So the FN will have. So that's just something important to take note of, especially when you are transferring parts across them, and including the keyboard and the trackpad. So because if they look the same and you feel like, okay, maybe I can use the key, no, it's not going to work. Okay, so this is coming in for no power, I believe, because it says it is board level. So as usual, the first thing we are going to do is we are going to define what state the device is in. By doing so, we are not going to connect power to it until we can confirm that this is the state of the device. So let's quickly take the board out. If this is the first time you're doing this, understand that the screws are of different sets. So we say this is what? Did we say this is Intel or M1? This one? Hmm? M1, okay. Okay, so usually when you open up a machine and it looks so clean, not touched, there's no signs of previous work. This is what technicians like to see. Nobody like to work on what has been worked on, because when you work on jobs that has been worked on and it wasn't successful, it's a bit difficult unless the person who did the job sits with you to explain to you exactly what was done and why what was done to it. So this looks very good, which is also very consistent with this particular company. The jobs that we get from them are not have not been tampered with. They do their assessments, but they do not tamper with the boards. Okay, so that's about that. The first thing I would do after the back cover is out, what will be the next thing that I would do, Shahid? Yeah, I'll disconnect the battery or any form of power that is currently connected to the device. So right now, primarily the two forms of power that your device will have will be your charger as well as your battery. Now, the battery designed for this particular machine, it has a dual battery design in terms of a dual battery communication. It has a data cable, which is how the battery gets activated, and it has the main battery power line. So the data cable will have a lower voltage line, and then the main battery power line will have a higher voltage line. Now, it's important to understand that if the battery that you have, if it's a generic, if the battery is not an Apple original battery, the calibration might not be 100% correct. So what I mean by that is this. So this cable allow me to disconnect. So this cable here allow me, the way this cable it's so you have on on this battery cell, so you have one, two, three, these are the battery cell. Now on the battery cell you have a mini board, correct, that runs to the battery. Now that mini board communicates to the main board via this you see this flap here, that's a main power line for the battery. Now that in itself does not activate the battery. So in order for the battery to be active on the board, you need a data cable, which is this cable here. Once I disconnect this cable, effectively there will be no more power from the battery to the board. So in terms of the power on the power that comes from the battery becomes redundant, no longer active. Now, if this is a Chinese battery, then which means there's a chance that the battery is not properly calibrated. Even when the cable itself is disconnected, the battery will still be active on the board. So that's the difference between making sure that the battery is original, as well as making sure that you are using or in cases where you're using an Apple original battery. So that's that. So we are going to just do a quicker measurements. Let's remove the battery main screw. Okay, so this board, the board view, let's open up the board view. This is going to be an 820-02020. Please help me with the phone. Bring the phone for him.
Yeah.
Okay, so this is the board view of the machine that we have. This is an M1 board view. The first thing we are going to do is we are going to check around to see if we have a short across the board. So right now we are going to make use of what is easy. We are going to check to see if we have a short on our PP bus line. We can check using a fuse on the PP bus line. You see, whenever you see F, that it's fuse. F will stand for fuse. Now it says if you see on one side, that fuse is sitting on two separate lines. So one side says PP bus underscore AON. Remember what AON means? Always on. Now on the other side is sitting on PPV bat. What do you think PPV bat means? Yeah, PPV, voltage for the battery. It says it's AON. And what is that? CHGR. What do you think that will mean? Charger. And then regulator. So you have a PP. The fuse is going to be sitting between them. So we are going to see, and that's a PP bus line. And another thing I also want to mention, remember the board does not need an extra PP bus created when you are working with the battery. What does that mean? The board the board creates PP bus voltage from a high voltage line. However, the battery itself outputs PP bus voltage. Do you understand? So the battery itself outputs PP bus voltage. The charger takes a high voltage and then splits it down to your PP bus voltage. Okay, so we are just going to see what is it that we have. So for two places that we are going to check to see if we have a short, we're going to see if we have a short on our PP bus. We are going to see if we have a short on our 5-volt line, which is UC300. And then we're going to see if we have a short on our PP3V3SON. Let's see, no, that's main. Let's see, PP bus. Okay, on this line here. But hopefully, okay, yeah, we will look for because board isn't out, so we'll see where can we measure that line without having to take the board out. Okay, we can measure it here on RC421. So that we can measure, and that will be here. We can measure it here. I measure there. So these are the lines we can. These are the rails we can check while the board is it's not out yet. So first thing first, let's see what is it that we have on our PP bus. In order for us to do so, we have our multimeter set to continuity mode. We have our black probe to ground like that, and then we have our red probe on our PP bus line, and we don't seem to have a short. That's fine. The next thing we're going to do is we're going to check to see if I have a short on this line here. Same thing. We have our red probe on ground, black probe on ground, black probe on ground, and then red probe. Let's see, we can check on this inductor here, and we don't have a short. That's fine. And then on the PP3V3 underscore AON, so we can check on this line here, and we don't have a short. Okay, that's fine. So the next thing we're now going to do, we clearly see that we don't have a short on, so which is there's no direct threat in connecting power to the device. So let's now connect power to the device and see what is it that we have. So power is connected. Let's see, what do we have on PP bus? By the way, this is going to follow the similar design in terms of fan management. So fan is not going to spin at all time. Okay, so it's black probe on ground and then red probe. Let's see what do we have on PP bus. Okay, so 12.33. Okay, is it stable or fluctuating? Because that's a boot-in voltage. 12.0. Okay, so that's not stable. So that would mean that now it's not stable. So if we get in, if this was stable, this will mean that the device now is not. You see that? So it means that we have an unstable line. So from the charger itself, we're getting an unstable line. So most likely we're getting 5 volt, and then obviously it's not able to get the 20 volt that is required. So That's fine. The next thing, obviously, in that state, the device is not going to start. And by the way, this is okay. Interestingly, we have haptic feedback. We have trackpad feedback. Okay, so what we are going to do while in since we have trackpad feedback, let's see, and it dies. Oh, okay. So what happens is so and just see that again. The trackpad activates and it dies. So we have 12, and then it moves down to now that is booting voltage. So basic not booting voltage. So that's basically the device going into SO state, but it quickly dies again. So because it's doing that, what we are now going to do is we're going to see what's happening and see if it's an issue with DFU. So we are going to first of all see if the device is stuck on recovery, and then we'll take it from there. Now, if you are going to manage your device in DFU mode, if you're going to manage your device in DFU mode, the way you manage the way for the Intel is not the same as M1s and the M series. So for the Intels, it doesn't matter uh, what port you use on your host, but the target device, if it's M1, is the first port, and then if it's Intel, it's the second port, and that's on your left. You will find some, and this is only devices with T2 chips and above. T2 chips and above, so it's T2 or your M series. If it's an M series, if it's an M series device, you use the first port. If it's an Intel, you use the second port, and this is on your left hand side. Say for example, if you have a 15 inches or 16 inches Intel device that has 4 ports, you're not to use the port on the other side. You're going to use the port on your left hand side, and it's the second port if it's Intel. But if it's M1, it is the first port. So what we're going to do now is we're going to connect to the first port, and we are going to start the program, which is and then on your host device, you must make sure you have Apple Configurator too. Did you download that? Okay. Okay. So let's see that. So we have trackpad feedback, and then it just dies. Okay, and then it comes on again. So let's see. We see that the device is not okay. Let's see if we can get it to go into DFU. Nothing. Let's try again. Nothing. Let's try again. Nothing. Let's try for the last time. Okay, device isn't going to DFU mode. Okay, that's fine. Let's take the board out and get to understand what's happening on the board. And also, if the device was stuck on recovery, we would have seen it immediately after we connected it to the secondary device. this is the first time you're doing this, it's important to take note of the screws, the sizes, and where they are placed. Do you have the 3.5? The 3.5? Do you have it with you on your desk? Okay. So while I'm busy like this, if you have question, I believe this is a better time to ask. I mean, because when you're watching the video, for example, you there's nobody there for you to ask. So if something isn't clear, I think this is the best time to ask.
So in the beginning, we first remove the battery.
Yeah.
So it's powerless. No?
Yes.
And then you connect this laptop to the TV.
Not to the TV, but to this machine. That's another computer, but without a screen.
What does PPV stand for?
He's gonna tell you.
What does it stand for?
So another thing is, so there is one very interesting thing about power lines or about MacBooks. So there is this phrase where they say just move on. For example, uh, if somebody introduces themselves as my name is so and so, what is the primary reason behind that name? It means to address the person, correct?
Yes.
You're not necessarily going to ask the person, so what is the meaning of your name again? Should they tell you the meaning of the name? Hmm? When you're addressing them, are you going to address them by the meaning of their name or by their name?
Yes.
Exactly. So Apple has this thing where, say for example, we have a line here that says pp pp3v3 underscore AON.
Who's on?
Yeah. So the first thing that I need to understand, in order for me to read this or for me to translate this translates into 3.8 volt on this line. I should have 3.8 volt on this line. Now the other one says AON. This voltage must be present, but there is a condition. The condition is that you have power in the first place, correct? This machine itself, the board will have two power sources. The primary will be the charger, and the secondary will be your battery. Now, also your primary can as well be a bench power supply. So you have a primary power supply and a secondary power supply. Whatever form of power that you have, it says, provided you have power, this voltage must be present. So if I come here, if I'm reading my schematic and then I say PP3V3, PP3V8 underscore AON, and then I ask myself, so what is PP? So PP itself stands for power plane, but it's irrelevant. The information that we need here is to understand what voltage are we supposed to have, what voltage is supposed to be here, and when is that voltage supposed to be present. Boss, how are you? Good.
Okay, so the main thing is looking at the voltage numbers and then seeing if it's present.
No. When is supposed to be present? How is it supposed to be present? When is it generated? Yeah, but that's high stuff for you now. Don't worry, you get to understand it. But that's just the question that you asked. I just needed to respond to it. Okay, so board is out. So let's look at the board, see if anything stands out. The board seem fairly clean. Let's try to dust it out. Okay, so the next thing we are going to do is we are going to see what is it that we have on our PPDC in. Okay, I actually see something that we have a bound component here. This guy here, it's bound. That it's a diode. Let's see what line is it on. There's one of these guys here, the D's. This is one of these diodes here. So it's the fourth one. So if I count 1, 2, 3, 4, the fourth one. I see a bunch mark on this side here. So I'm gonna see, and that goes to what? Yeah, 400. But that's not present on the board. No, no, no. It is present on the board. That's the CD3217 EF400. Okay, so let's see on the other side. Do we have here to uh okay. So and that corresponds with the first port, correct? Remember we tried DFU and there was a response, so that actually makes sense. Okay, so what we're now going to do is we are now going to so we were going to check the other this other side of the board, but now because of that information, so first and first we are going to check around this guy. We are going to do a continuity measurements, not a voltage measurement. So let's check this guy, see what's happening, see if we have a short. So that is 039, and then the other one is what? It's 531. Let's check the other one. 039. That seems low. Let's check on this other side. Is it the same thing? OL. Yeah, so that's definitely low. You see that? So that's 039 and 03, and then another thing you want to understand is, you see, one reason why our focus is kind of locked to this section is because of the component that we saw on the line, and because the line is, we see that the line directly has a communication with that chip, correct? Otherwise we wouldn't start up. Yes, we were going to start from see what we have on our PPDC in. We're also going to see if we have what is it that we have on our board. So but see that line 04, that's low. That's low. I'm gonna just get another board. Okay, so that line, before we, so let's come here. So this is the line that we say it's low. There are two capacitors here. C stands for capacitor, correct? Okay, so we have C here and then we have C. So when we click on that, we say that it has a direct communication with the CD3217. And when we also click on the VP3V3 underscore the LDO, so that also has a direct communication with the chip itself. And the reason why we're focusing here is because of the bounce back that we saw on a diode. So that is what we check, and that's considerably low compared to, let's see, on another board. Let's see what we're supposed to get on that line. See that? That's on another board. That's what we're supposed to get. We're getting 4 figures, correct? But on the board here, this is what we're getting, 0 point. Yeah, so we definitely have a problem. So what we are going to do is we are gonna remove so we are going to remove that diode, and we are also going to replace that. Okay, so let's get to work. So first thing we're going to do is to remove the diode. It's not connected. Okay. Actually, oh yeah, we have a new 0.8 scooter in case 0.8 for the antennas. See that? We have a new one there. Not open in case you need. And also now you need to help him set up the desk, the screws, and show him the type of screws you use, and probably you have to give him that 0.8, and then maybe give him, I don't know, just set up his desk for him. Just make sure he has everything he needs. Okay, first let's remove the diode. Okay, diode is out. So let's just check again on the LDO before we replace it. Yeah, still low. That's 0.5, something like that. So let's remove it. And by the way, the only reason why we're removing F400, it's because of obviously the diode that we saw that got burned, and also because that is the main character on that line, correct? So we are not hoping that. So in in other situations, we might not we might not take out the CD itself. We might probably want to look around the capacitors that are tied to it. But given the fact that we have a bond, so that's why we are going in this direction. Okay, so that's out. Let's check again to see if we still have similar reading or if our reading is now okay. See that? Hmm? So now the reading is fine compared to, so which is, our problem is this guy here. Okay, so let's get another one. the diode, let's see. Okay, so we have replaced this guy here and this guy. So usually in cases like this, you also want to check the charging port itself just to be sure that it's not going to be any existing because you don't want to, you're not sure exactly why there was. Okay, okay, charging port, it's fine. Okay, hopefully the kind's charger is also fine. Okay, let's see, the replacement was good. see if we have a short across. Now we now have a better reading. Okay. Okay, so let's see what do we have. People just say, oh, three 3.3, that's fine. 1.8, that's fine. We have 20 volt of uh, 5 volt, let's see. 5 volt and still fluctuates. Okay, let's see, check the other side. Okay, 5 volt. It's fluctuating, which is a good sign because it seems that it's trying to boost. Let's check the second port. So both okay, let's see if we have something similar to what we had before. 12.3 doesn't move, and this is more quicker than before. So both ports, okay, let's see, that's present. Okay, let's put it in the shell. See what's let's see if we can get the device in DFA mode now. We might also again have to come back to the CD3217 that we replaced, just to because if it's not properly soldered in place, we obviously are not going to get 20 volt out of it. Okay, just some of the only the cables that we need are connected. Second port. Okay, so not stuck on recovery. Let's just try again. Okay, still doesn't go into AFU. So we have trackpad feedback still, and then it just dies. Okay, still have trackpad feedback. See what else. See what else is going on the board. See what else we can see that's present. I vote. Let's not go past 5 vote. Mm, okay, and the other one. short in any of the secondary lines. Okay, so we don't see anything that stands out. So which means we have to focus still on the PPDC in voltage. Let's just confirm something. Okay. Use the diode load measurements just to compare both readings. Five 510, 515, 510, 515. The device actually does go into SO. Let me use a different shell just to test it, see if it's going to DFA.
So what number are you looking for?
Consistent.
Consistent.
Yeah, so I'm supposed to get 20 volt. I'm supposed to get 20 volt on PBTC in, but PBTC in is getting I'm getting 5 volt instead of 20. Let's check this shell. Let's try to use a different shell. We're going to only connect cables that are currently required for the testing. Let's have check that feedback, and we have hmm. So it doesn't behave the same way as so this here. Let's see. Hmm. Okay. Let's see if it's gonna. Okay. Okay. Let's see something. Okay. So the fact that we get a low battery sign on the screen, that tells us that the board itself is fine. The only problem that you're having is this point here. We only have a problem in this point, either this guy or this guy. So we know that this was we had a problem around here because of a short which was around here, which we replaced, and now with the short is gone. Um, what we the, inside, so the reason why we had to use this shell was because there's still a bit of juice left in this battery, so that will be able to show us that the device itself needs the device is just needs to be charged. The board itself is fine. Other section of the board is fine. The only place we need to worry about is this place here. The two CD32 R17. Now they both seem to be fluctuating, which is one behind the number one. It could be that this was not properly soldered, which we'll probably have to do again, or we might have to reprogram UF2600. So this is the ROM chip for both CD3217s. So what we are going to do first and first is before we redo this, we can okay, let's see, we can either redo this quickly, or we can program U5060. So which one should it be first? So we can reprogram this, or we can redo if U50 UF400. Because our problem is definitely here. The device is not charging. So, but beyond that, the device itself, the board itself, didn't have a problem. So the board just needs to charge. So if we put this board, if we put this board on a charged shell, it will start. So we just need to get it to charge, and then we just need to get. So we can either redo this. So we can either redo this guy, replace it, or we can flash U5260. Which one should it be first? Flash that first. Oh, okay. Okay. Uh, okay. So now to flash that, we need a Windows device. We need a tool. Okay. So so we flash. Okay. Hmm. Okay. Yeah. Let's do it. Let's flash it. Yeah. Yeah. Let's flash it, and then also give the phone time to charge. Okay, this is an update on the M1, the one that we needed to flash the ROM chip for the USB 32 for the USB, which is the USB controllers, the CD3217s. Shahid, the guys are gone, so I'm kind of holding the camera myself and also trying to show you guys what I'm talking about. What I was supposed to, reprogram U5220, but I couldn't do that because I needed to use a Windows device, and the Windows device was supposed to come from downstairs, which is and then I waited, but I didn't get that on time. So they left, and myself, so what I had to do was I had to just take U5220 from another functional board, and then I installed it on the board, and it worked. But before I did that, I needed to be sure that this is not about. I needed to be sure that this is not about um, uh, not properly a U50 a CD3217 that is not properly installed. So I had to again remove UF400, and then I redid it, and it didn't make any changes. I had to also remove UF500, and it didn't also make any changes. And also, I didn't really go further into the board because we've already confirmed that the problem, because the machine power is on, and also the other time we checked with a partially charged battery, we could see that the battery charging sign, which is to say that we don't really have a problem inside going past the CD3215s. So I was pretty confident that our problem has to be in the region of the CD3217. Sorry, I keep saying CD3215, CD3217s. Um, so basically I couldn't still get to to flash UF20. So UF260, I couldn't get to flash it because I still didn't get the Windows machine. So what I did was I had to just get the ROM chip from another working device, from another working board, and I installed it, and it worked. So yeah, that's about it. I'm just gonna. So the one thing I need I kind of I'm also going to observe it because yes, I didn't flash it, but then I took it from another a similar board, and then I replaced it, and then it worked. So I am gonna observe it between now and tomorrow, just to see that, because um, the ideal thing would be for you to flash it, but if you, I just want to see how, I mean, to flash its original chip. So I want to see how it performs and behaves, having with a different chip that is not its own, but it is working. So we'll just see how that plays out. But yeah, that's about it, guys. So what I had to do was replace UF260, which is a ROM chip for the CD3217s. And after doing that, the device powers on, it charges fine. And yeah, so this is the device here. This is the device here. And then as you guys can see, we are now, device is now charging. So that's it. The device is charging and the device is on. So if I'm to disconnect the charger, for example, so that's the charger disconnected, and the charger, the battery is actually charged a bit. This was the same shell that would not power the device, the same shell that would request that the charger be connected because the device was not taking power from the USB-C. And yeah, that's about it. And then, by the way, before I also replace the RAM chip, what I also did was I had to install the board in a different shell, and then just try to see if I get any form of output from the from the. So I installed the board in a different shell that has a charged battery. Obviously, in that state, it will power on, but will not charge. And then I try to connect a device to it, say your phone or your drive, just to see if I can get any type of communication from the port. But no, I didn't get anything, because sometimes if it is that you have a problem with one of the CD3217 or one of the CDs giving you issues, what will happen is you will be able to pick that up when you install the board on a shell that has a charged battery, which will allow you to power the to power the device and then put the device to desktop. So that way, the port that the corresponding port that has issue will not be able to read your drive or communicate with any external drive connected, but the port that is supposedly fine will be able to read your drive or be able to charge your phone, or do something, or show you some kind of a communication on the line. So even at that, I didn't get anything. So that further basically cemented my idea of having to make sure that having to go through replacing the RAM chip for both 3217. But then the thing also is, the failure pattern is something that I couldn't really connect. I mean, there was a spike on the charging line, damaged one of the CD3217, and I don't understand how that's supposed to also affect the ROM chip. But anyway, that is what we saw with this one, and yeah, this is it. The device is ready. I'm not gonna put it together. This is also, so I'm using a different shell. Reason being because, and then also another thing that you guys will notice. Remember when without the charge the battery, the device will not start. So the battery is disconnected now. I'm going to start the device without the battery. So yeah, it's a bit difficult because I'm holding it myself, and also yeah. So now charge is connected. Let's see, and that's it. As you guys can see, the device starts even without the battery being connected. Before now, as you know, battery not being connected, the device is not going to start. And yeah, that's about it. So I'm not gonna basically oh, by the way, you hear the fan spinning so loud. That's because it doesn't detect the presence of the battery. So I'm gonna wait for the guys tomorrow to do the assembling of the device. But other than that, I'm just gonna, maybe let me see if I can show you. Um, let me see if I can show you what I did. Sorry, I have to hold the phone with the camera with one hand, and the other hand I'm trying to show you. So it's okay. So this is the guy that I had to replace. I have cleaned the board as well. That's the guy. Uh, that's the guy that was replaced. let's see. I don't know if you guys can see that. So this is the guy that was replaced. So what I did again was I had to again replace the CD3217 to see if that will fix the problem. That didn't fix it. I even had to replace the second CD3217 to see if that will fix the problem, but that didn't fix the problem. So I then had to replace the RAM chip for which controls both. And after that, now I get my 20 volt, the device powers on without me having to have my charger connected. Now this is the other board that I actually got the SPI ROM chip from, this one here. So this is a fully functional board. So I took the ROM chip from here and then I used it on the one that is and the one that's not working. So I will have to either reprogram this, or I'm also going to put in another board, another ROM chip on this one from a board that is known to be working. Okay, guys, that's about it, guys. Thank you, guys, and I will see you guys in the next one.